Welcome to Clockspring 3D. Why am I holding this? Well, joining things together, joining the printed parts together is achievable in a multitude of ways, but this is my favorite. And I get a lot of questions about this, about how this is done. And what I'm talking about is just using threaded parts to hold printed things together like that. Now, the great thing about printed screw thread elements is that because these things are adjustable and tightenable, it really makes up for the variability in different printers and different slices and different workflows and whatever. But one of the tricky things with this style of approach is that if you've got an object that needs to print in that sort of orientation, then you can't just use that kind of thread because that's obviously going to be an overhang. But we can do something like this, which is not as complicated as it appears, but it's something that I've had a bunch of questions about. So let's have a look at how it's done. Now, this is something I use all the time. So it's the same approach I used for the retention rings on the side of these Raspberry Pi cases, for example. It's exactly the same thing I used on this pen case as well. So, as an example, let's put together a box. Now, I have done a quick sketch of a concept here. So we're going to do something like this. How did that get there? This is what we're going to do. So basically, the different colors just indicate different objects. We're going to have a box with a top that sits on the bottom. It's going to slide over the top. And then we're going to have a screw element that joins the two together. And we'll probably put one on each side as well. So let's start by making the box. Now I'll fast forward through this because that's not really the focus of this video. So let's put that together and then we'll work out how we're going to add this retention mechanism to the outside. Okay, so now we've got our basic box here. So let's have a look at that. We've got a lid that slides over the top of a base. And as you may have seen in the sketch, well, this sketch, we've got some plans for some sort of round thing here. Now, this is where we get into what these thread things actually are, like these funny angled things, and all they are is a threaded part that is truncated at 45 degrees so it'll print. Now we should bear in mind that half of this threaded part is going to be attached to this lower base section and half is going to be attached to the lid so that they can be attached. Now the lid is going to print with the top down, so both sides are going to need to have concern for potential overhangs here. So that aside, let's just create a thread. Now I'm doing this in Fusion, but you could do this in anything. You could do this in Tinkercad pretty easily as well. So let's just pull that out. I'm going to pull that out 5 and so this is where we get into the kind of threads that I like to use. Now, most packages will have some sort of tool for creating, standard threads, whatever. I like to make things printable. And I tend to find that by making threads a little bit more elongated to just ease some of the angles, things print a little easier. So when I'm creating this initial cylinder, I actually want it to be half the length that it'll end up as, because I'm going to create a standard thread around it and then I'm going to stretch that out. So just bear that in mind as I go through this. So let's create this as a new body and let's remove that sketch for now. So that's just kind of sitting there in space. Let's create thread around that, and again use whatever tool you've got and work appropriately. Now I'm literally just going to make this a standard isometric thread, and there we go. Now it's completely arbitrary in terms of the size of this thing, so let's just do what I was talking about and stretch this thing out. So in the case of Fusion, we'll scale that non-uniform and just across that axis, and look at that. So we now have the basis for the, what are we calling this thing? The bit that the nut part will screw onto. So the threaded components that were part of the box. Now, before we do anything else, let's just take the opportunity to create the thing that's going to go on the outside. So in this case, I'm just going to go create a cylinder, make it concentric with that, make it the same length as that. Obviously we want that to be a new body. Now, I am going to quickly duplicate, let's remove some of these other things. I'm going to quickly duplicate this screw thread and put it in exactly the same spot, hide the original, because this is where the tricky thing comes in terms of creating parts that will screw together. Now, obviously what we need is some kind of tolerance. We need a gap between the two parts so that they will actually move together. If the dimensions were of the, if we just took this and cut it out of the screw nut part, then there's no way that they would actually screw together in reality. So we will use the shell command. Now, if I was doing this in Tinkercad, I would literally just create the same thread, but, well, I would create a thread with a 0.5 millimeter greater radius. Same effect. So in this case, outside thickness of 0.5. There we go. Now, if we bring back this thing, and we go cut. Now this is actually going to leave remnant in the middle because of the way I did it. So we'll just pretend that didn't happen. So there we've got the bit that we're going to screw on. Now let's just put that aside for now and go back to this. Now we have a division between these two parts. So we are going to need to cut this whole cylinder thing with the thread on it right through the middle so that it will be in line with those. Now there's many ways you could do this, but I'm just going to do it the fun way and use a box on that plane, and that's going to go all the way down to that. Move it not too far. I suppose this wasn't the easiest way, but I don't know. I like doing it this way. Okay, so now we have cut that thing in half. Right, but that's still not printable because obviously this is a huge overhang, and likewise, considering that this part here will be upside down, another huge overhang. So what are we going to do about this? Well, we're going to cut it at 45 degrees. Now, if we go back to that sketch that we had, let's actually just go back and edit the sketch. Now, there's so many ways you can do this as well. Now, in Tinkercad, I would just create some kind, like a cube on a 45-degree angle, and shift it in until it was in the right spot. Actually, you know, let's do it that way in Fusion too. So let's go create box. We'll just put it here for now. Okay, this is just going to be a cutting thing. So go new body, and then we want to move this. So let's, for a start, just rotate that to 45 degrees. And then we're going to move it in place. It doesn't really matter exactly where it ends up, because the point is that we want to remove the start and everything at 45 degrees up from it we can move it further in, and that's fine. We just can't leave it sitting out here so that we have remnant overhangs. So we need to have it, let's put it there, that's fine. And how are we looking? Oh, that's not useful. Let's bring that in. Okay, so that is now something we could use to cut with. Now, I'm a sucker for a little bit of symmetry, so I'm going to just make sure it's the same for the top as well. And I'm going to do that in Fusion by grabbing a midplane between these two surfaces. And then I am going to reflect this whole thing. That over there. There we go. So let's do some subtracting. So we're going to cut. Oh, that I forgot that was a new feature where you could have it joined automatically. I wonder if we can select two target bodies. Well, that didn't go well. Let's see. Target body. I'm just going to go back to this mirror operation and make it a new body. Just to be simple. And we can hide our construction stuff. Okay, so we'll chop that off there. We will chop that off there. And lo and behold, that may look very similar to these things. And that's pretty much it. Because the secret to this is that there's enough thread left on the side here for it to work perfectly well as a retention mechanism. So let's just unhide that thready thing. And you can see there's just a little gap. Which is what we need. So let's make all this a little bit more interesting. So and let's just make some cutouts. We don't want to we want to make sure we don't accidentally chop our way into, oh, that's not going to work. We want to make sure we're not going to accidentally chop our way into the thread, so just something to be aware of. And let's just, that looks alright. Again, it doesn't really matter where these things are, it's completely arbitrary. And let's put a circular pattern around that just because we can. Okay, so that's looking good. Maybe just put some more nice little touches on the box itself. We haven't done this side, have we? But that's alright because these are still separate objects anyway. So now I created this across the axis, so we can probably just go create. Oh, I almost made the worst mistake possible, which was to mirror these things. You never want to mirror threaded components because then you'll reverse the threads, and suddenly you'll need a reversed nut as well. So we don't want to do that at all. What we want to do is just rotate all these things around the axis. Now, where is that? Yes, that is right. So rotate that and copy. There we go. Looking good. Now we should be able to just join these things. And oh, what happened there? Okay, so by the looks of it, Something's touching something that it shouldn't be able to. Let's just hide the cog parts. Oops, nope, that. Just do this again. So those bits joined. Okay, so now we have our two parts. Let's just see interference between the two. Oh, okay. Looks like it's all fine. Though we can, of course, go into a section analysis and just shuffle down, make sure things look the way they're supposed to. And down the bottom here, all looks happy. So, there we have our box. Let's just flip this over. Doesn't have to be exactly in the right spot, but let's just do a quick sanity check. How does that stuff look? All looks pretty reasonable. And then we have these things which will obviously, ooh, let's just rotate that along a more useful axis. Okay, so all of these parts are ready to print. And that's it. So the lid pops onto the base and we can screw these things on to hold it all together. And there we go. I really like using this just because it's so reliable. It's resilient in the face of different print settings and filaments and printers and whatever else. It's just a matter of tightening it or loosening it accordingly. So it's something that has such a broad range of applications, and I encourage you to do something cool with this as well. So hopefully that gives you enough inspiration and an introduction to how this is actually achievable. I will be putting this design up for my patrons. I have the best patrons, and I cannot tell you how much I appreciate the support of my wonderful patrons, without whom I wouldn't do half the things I do. So anyway, I will put this design up, but you should design something better, something more interesting yourself anyway, because it's 3D printing, and that's why we have 3D printers. And I'll stop waving this box around now, and I will see you next time. Keep printing. Things stay together and making your lights fall off the table. 3D printed diffusers.